Assalamu alaikum guys, our topic for the project is scapegoat trees. The following people are in my group and we will start right away. We'll be first discussing its characteristics. So basically there are type of cell balancing trees just like AVL or red black. However, they do not store huge amount of extra data at each node like colors or weight. In case when rebalancing is needed whenever an add or remove operation is performed, it starts at leaf and it ends at a special node identified as the scapegoat node. And throughout the rebalancing, the tree performs different strategies on height and weight to do the task successfully. And finally, these trees are well known for optimizing search and add operations. So moving ahead, the advantages are that balancing can be achieved without rotations and no additional memory per node is required. Furthermore, it also contains a parameter alpha that decides how balanced a tree should be in its living time. The only disadvantage is that it takes omega n in reconstruction of the tree, and therefore frequent reconstructions can waste a lot of time. So this is a comparison table we got of red, black, splay and scapegoat trees. We can see that at different sizes of tree, add and find operations are performing way better comparatively. Moreover, delete is also surprisingly giving us better results.
Now I will discuss the problem that we're going to address through our project. When we were doing research, we decided to work on a topic related to sustainability, and we all agreed upon carbon footprint that is generated by our food. This is a problem that is usually overlooked in Pakistan. So carbon footprint is the total amount of greenhouse or toxic gases generated by our own actions like deforestation. So the food that we eat include ingredients that are mostly produced from industries which use fuel and produce toxic waste or greenhouse gases, and it all counts in carbon footprint. So this carbon footprint results in a lot of consequences like the change in climate or extreme weathers, and like depletion of resources or industrial impact, and hence we need to think about a solution so we can avoid this carbon footprint and we can improve our lifestyle.
Our solution is to use the information in your food, compare it with the database of ingredients, and give you a report on how many tons of carbon you are adding to the environment by purchasing that food. We will use an image of ingredient scan from the back of the product. Using optical character recognition packages of Tesseract, we will convert the text in the image to a readable file, and each entry of the new file will be our input. Next, we will use the database stored in a scapegoat tree and apply a search operation for each entry. If there isn't a particular entry, we will return with a nil value. All the ingredients with your carbon footprint values will be presented in an Excel sheet as an output. Now it's all the information you need to make an informed choice. A little about the database. Carbon footprint values are calculated using the data on each ingredient's calorie content, production, and other factors.
So for the next coming weeks, we have categorized our work into three major categories. The first one and the most significant is the proper implementation of the scapegoat tree in Python, for which we will have to be constructing the node structures, then we will be implementing the different operational functions like addition, removal, and finding, and then we will be verifying the correct functionality of these functions. The second category is regarding the construction of a compatible dataset by refining it, since the dataset that we have found includes different parameters from which we'll have to manually calculate the carbon footprint. So we will also have to devise some sort of algorithm for that, and apart from that, the user input of the ingredient from the food will be taken using the OCR based implementation of the GUI that will take images as an input and will give carbon footprint as the output. And the last category is the integration of the GUI with the implemented data structure and connecting the functionality of the data structure operation output to be displayed on the GUI. And as far as the work division is concerned, Alisa and Vasi will now be working on the scapegoat tree implementation, and Ammar and I will be looking into the OCR implementation, defining the dataset and calculating the carbon footprint. And towards the end weeks, we will all be working together on the GUI integration and merging the overall project into one single entity, having had a good idea of our inputs and outputs from our implemented data structure and the GUI.